That is, bam, right there. So the y value at f of 0 is 4. So that's going to be g of 4. Well, what is g of 4? Okay, we're going to look for 4 as the x value. It's right here. And then where is my g? G is right here. So what is the matching y value? The matching y value is 0. So g of f of 0 is 0. Okay, go ahead and try to see if you can find f of g of 3. Okay, so we're going to look for g at the x value of 3. So x of 3 is here. G here is that point, which is corresponding to -1. So that's going to be f of -1. And then we want the f value at -1, which is going to be right there, which looks like, well, 2.5. Okay, so f of g of 3 is going to be 2.5. Okay, notice lots of parentheses going on here, so be careful. Make sure to use your parentheses wisely. All right, last one. G of 1. Okay, so looking for the x value of 1. Boop, right there. Go for my g value is 3. Okay, so that's going to be g of 3. And then what is g of 3? Well, here's my 3 value. Looking for the g function, it's going to be right there. Corresponding y value, -1. So g of 1 is -1. All right, moving along. Okay. Example 5. Let f of x equal x squared plus 1 and g of x equal square root of x minus 5. Find the following compositions. Notice I don't need to find the domain because we're doing composition. Oh, but interesting, this time we're not given a specific x value to solve for, so we're just inputting the two functions together. So f of g is going to be f and input the g value. So that's going to be f of, what's my g value? Square root of x minus 5. And let me actually just color code this. So what we're doing is taking this and plugging it in to my function f of x. So my input value, this is my new input. So what do I do with my input? Well, I square it, and then I add 1 to it. Okay, though when I square, the square will cancel that square root, and so I'm left with x minus 5 plus 1, which is going to equal x minus 4. So f of g is going to equal x minus 4. And if you can write your final answers with the f of g equals and your answer, that would be great, and then box that. Thank you. All right, g of f. That's going to equal g and input the f value. So g of, what is my x function? F function is, let's go with x squared plus 1. Inputting that into my g function. This is my g function. So I have my input minus 5. And that's going to equal the square root of x squared minus 6, which we can't actually simplify because that is not a perfect square number. So we're left with that. So g of f equals square root x squared minus 6. Next one. f of f. So f of f is going to equal f and input f. So let's see, f inputting f. My f value is x squared minus 1. Plus 1, excuse me. Oh, I see my error in my ways. Aha. Sorry, going back to the original one. That should have been a plus 1, which changed this to a minus 4. Sorry about that. But still, that is not simplifiable. So we're left with that. Sorry about that. Okay, keep chugging. Here we go. X squared plus 1 squared. Ooh, plus 1. Oops, I forgot to color code. Okay, so what we did was our new input value was x squared plus 1. So I'm inputting that in here and squaring it. So my input value squared plus 1. This is going to equal, so that's going to be foiling it out. Let's see, x to the 4th plus 2x squared plus 1 plus 1. So simplifying that, I'm going to get that f of f is equal to x squared, x to the 4th plus 2x squared plus 2. And lastly, g of g. So g of g is going to equal g, inputting g, which will be g of, and my g function is square root of x minus 5. So inputting that into my function, I get the square root of my new x value, which is square root of x minus 5. So the square root of x minus 5 minus 5. And we cannot simplify that. So there we be. One more page to go. Lastly, okay, so we are given 1, 2, 3 functions. So we have f of x equals 1 over x, g of x equals the square root of x, and h of x equals x squared plus 2. So we've got a quotient function, a radical function, and a quadratic. And we're asked to find f of g of h. Whew, lots going on. So rewriting this, f of g of h is going to be f of g of h of x. Once again, parentheses are important. So let's go ahead and start with h of x. That's the first one we're going to put in. So that's going to be g of, and what is my h of x value? Well, it's x squared plus 2. Now we're going to take that and input it into our function. So our new input value is going to be that. So my g function, let's see, we'll use purple for g. That's going to be the square root of my h function, which was the blue. Well, we can't actually simplify that. So let me just clean up without the parentheses. So my new g function is going to be x squared plus 2. Now we're going to input that into our f, which is right there. So my new input value is going to be the square root of x squared plus 2. And f tells me to take that and put it under 1. All right, but we're going to go ahead and rationalize this because we're not allowed to have a square root under the denominator unless told so otherwise. Okay, so how do we rationalize this? Well, multiply by the conjugate. Actually, in this case, we don't have a conjugate. We just want to make this as some value squared because our goal is to get something squared so we can cancel the square and the square root, which means I want to have x squared plus 2 squared. At the moment, I only have x squared plus 2. So to get x squared plus 2 squared, we're going to multiply it by another x squared plus 2. And we have to do that to the top as well, the building up property. So once we do that, under the denominator, we're going to get the square root of x squared plus 2 times the new x squared plus 2 that I've multiplied in. And when I get that, I now have my goal, which was to have x squared plus 2, since there's 2 of them, squared. And now that cancels, and I'm left with the square root of x squared plus 2 all over x squared plus 2. And that, my friends, is FOGO, or f of g of h. Oops. Okay. So unless the directions tell you not to rationalize, you should always rationalize and make sure that there is no radical in the denominator, unless you want to be sneaky and make it a fractional exponent. Okay? And there we go, f of g of h. That is the composition of functions. Here is your written homework, which is due by the end of the week. And please remember to do the online homeworks as well. Email me if you have any questions.